Have you ever wondered how doctors measure your blood pressure using that tight cuff around your arm? That device is called a sphygmomanometer, and it plays an important role in detecting health conditions such as hypertension or high blood pressure. In this video, I will explain what a sphygmomanometer is, its main components, the physics principles behind how it works, and finally, how blood pressure is measured step by step. A sphygmomanometer is a medical instrument used to measure blood pressure, which is the force exerted by blood on the walls of arteries. Blood pressure is recorded using two values: the systolic pressure, which occurs when the heart contracts and pumps blood, and the diastolic pressure, which occurs when the heart relaxes between beats. A normal blood pressure reading is approximately 120 over 80 millimeters of mercury or mmHg. A sphygmomanometer consists of several important components. First, the cuff, which is wrapped around the upper arm and used to apply pressure. Second, the bulb pump, which is squeezed to inflate the cuff. Third, the valve, which controls the release of air from the cuff. Fourth, the manometer, which measures and displays the pressure. And finally, the stethoscope, which is used to listen to the blood flow sounds in the artery. All these components work together to produce an accurate blood pressure reading. Now, let's explore the physics behind how this device works. The sphygmomanometer operates based on three main concepts, which is pressure, fluid flow, and sound waves. First, pressure is defined as force acting on a given area. P equals to F over E. When the cuff is inflated, it applies external pressure on the arm, compressing the brachial artery. If the cuff pressure is greater than the blood pressure, the artery becomes completely closed and blood flow stops. In traditional devices, pressure is measured using mercury based on hydrostatic pressure, P equals to H rho G. This means that the pressure is proportional to the height of the mercury column. That is why blood pressure is measured in millimeters of mercury or mmHg. Next, we look at fluid flow in the artery. Blood behaves like a fluid flowing through a tube, and it can flow in two ways: laminar flow, which is smooth and produces no sound, and turbulent flow, which is irregular and produces sound. When the artery is partially compressed, blood is forced through a narrow opening at high speed. This causes the flow to become turbulent, creating vibrations in the arterial wall. These vibrations produce sound waves known as Korotkoff sounds, which are essential for measuring blood pressure. So, overall, the measurement depends on the interaction between cuff pressure and blood pressure, which determines whether blood flow is blocked, turbulent, or smooth. Now, let's go through the process step by step. First, the cuff is inflated until the pressure is high enough to completely stop blood flow in the artery. At this stage, the artery is fully compressed, so no sound is heard. Next, the cuff is slowly deflated by releasing air through the valve. As the pressure decreases, blood begins to flow again, but only partially. The first stepping sound that is heard through the stethoscope is called the Korotkoff sound, and it indicates the systolic pressure. As the cuff continues to deflate, the artery opens more and the blood flow becomes less turbulent. Eventually, the sound disappears completely. This point indicates the diastolic pressure, when blood flow returns to normal and becomes laminar. There are three main types of sphygmomanometers. The mercury sphygmomanometer, which is very accurate and uses a mercury column. The aneroid sphygmomanometer, which uses a mechanical dial. And the digital sphygmomanometer, which is automatic and commonly used at home. So, in conclusion, a sphygmomanometer is not just a medical device, but also an excellent example of physics in real life. By applying concepts such as pressure, fluid dynamics, and sound waves, it allows us to measure blood pressure accurately. This shows how physics plays an important role in healthcare and helps improve our understanding of the human body.